I know that a and b are different numbers. So I can break this down into a over u minus a plus b over u minus b. And what's big A going to work out to be? Well, x equals little a is what makes, or excuse me, u equals little a is what makes this denominator 0. So I'm going to cover up that factor and plug in u equals little a, and I get negative little a over little a minus little b. For the coefficient big B, I know that it's b, little b, that makes this denominator 0. Cover up that factor, I get little b over little b minus little a. And so this partial fraction decomposition gives me, so if I want to integrate this using the partial fractions, I have this constant minus a over a minus b times the integral of 1 over u minus little a du plus this constant times the integral of this. A and b are just constants. Alright? So when you integrate that, you're just going to get your standard natural logs. Okay, so integrate this as usual. I get negative a over a minus b, natural log absolute value u minus a, minus b over b minus a, natural log absolute value u minus b, plus of course some constant. And so back into the differential equation. I'll throw the constant to the other side with the other constant. Okay, so now we just have a bunch of back substitution to do. The first back substitution to do is we'll get things in terms of x's and y's again. So u, or y rather, is u times x. That means u equals y over x. So this is negative a over a minus b, natural log absolute value, y over x minus a, minus b over b minus a, natural log absolute value, y over x minus b, plus natural log absolute value x plus c. These y's don't look too good. Let's put those y's in a little bit better. Okay. So now we have to go back and figure out what the a's and little b's are. Okay, so here's the our solution to the differential equation. We need to remember what a and b are. A is 1 plus the square root of 2. B is 1 minus the square root of 2. So if I go to simplify these coefficients, minus a over a minus b is minus 1 plus square root 2 over a minus b is 2 square root 2. I can distribute the negative, rationalize the denominator, multiply top and bottom by square root of 2. I'm going to get negative 2 minus square root of 2 all over 4. So the square root of 2 is negative square root of 2 plus 2. Take the opposite of that and you get that. B over b minus a is 1 minus square root 2 over b minus a. That's going to be negative 2 square root of 2. Multiply top and bottom by negative square root of 2. I'm going to get 2 minus square root 2 over 4. Now I substitute these back in with all the other a's and b's, and let's see what I get. Okay, now here's the differential equation again. We have figured out what these coefficients are. So minus a over a minus b worked out to be negative 2 minus square root 2 over 4. ln absolute value y over x minus a, and a once again was 1 plus square root 2, minus b over b minus a was 2 minus square root 2 over 4. The natural log absolute value, y over x minus b, which is 1 minus square root 2, equals natural log absolute value of x plus c. We weren't asked to find an explicit solution, so we can go ahead and stop with the implicit solution. So of course the ultimate way to check your answer is to take the derivative and show that when the dust settles, you get the original differential equation. In other words, y prime is x plus 2y over y. And you might think, oh, you know, that's impossible to do. It's actually, you know, it's involved, but it's really not that bad. And it's really a very good review of everything in intermediate algebra. To be quite honest, that's really all it is. Once you take the derivative, the logs go away. Just remember your chain rule. And then it's just really intermediate algebra. So if you want to make sure you're the best with intermediate algebra, go ahead and take that derivative, simplify it, and show that you get this. That'll do it for quiz 3.